action. Okay, still 2020. Working on section 3.4, and just a quick warm-up. We are going to look at, what is it, these transformations on the graph of the square root of x. So, you guys had a moment to try them out already. So here's the square root of x, right there. Now there might be one or two transformations to get us down here. And it is a little bit of sort of some educated guessing and checking, right? Did anybody come up with something that works? So root x, a plus 3 inside, underneath the root? Yeah. Minus 2 on the outside. Okay, so let's see if it works. So this would take an xy coordinate and it would move it 3 units to the left and then 2 down. So if you just track those 3 points, those 3 key points, see if that happens. If it works, you go over 1, 2, 3, and then down 2. So there's that one. This one go 1, 2, 3, and then down 2. There's that one. And then 1, 2, 3, down 2. Perfect. So what was your strategy to get it? You just kind of guessed a bit. Yeah. Did you start with a point and then just try to? You're like, oh, I think that one went there. Yeah. And then you tried to figure it out. That's not a bad strategy at all. Just generally works. They don't give you anything too crazy difficult. Things to watch out for, like on maybe if you look at number 2. So here's the square root of x right here. So I'll just highlight it in red. And the transform graph is this one down here. Really quickly, I'm like, oh, 1, 1/2, 0 stayed there. So it's like it's probably some kind of vertical compression. What did you guys come up with?
Y equals 2x.
2?
Yeah.
Or is it 1/2? This works. You might be thinking, so for the y value, so this is something that's affecting the y values. What you see is what you get. Yeah, so that's going to take an xy coordinate, and it's going to do x, comma, 1/2 y. And that's what I noticed is happening. Like you got 1, which went to a half, and then 2, which went to 1. So it's half. And there was no like horizontal shifts or vertical shifts or anything. Yeah. I guess the big giveaway on that one, the key fact is that the point 0, 0 didn't move. Right, so that's telling you, well, it's not some kind of shift up and down, right? Otherwise that point would have moved. Okay, because you might have thought like, oh, well, that one went down 1, but that one stayed the same. So that's how you know it's some kind of a compression. All right, there's that. Today we're putting it all together. Before we do it, I just wanted to sort of take an equation and also review what an absolute value is. And just do one thing at a time to it and build it up to the final equation so we can kind of see like how all these things interact with one another, all these transformations. So number 1, if you start with the absolute value of something, what does the absolute value do? Yes, very good. So I just write abs for absolute value. You will get abs. So an xy point, basically any, let's say I have y equal x. Any negative y value is going to become positive. Okay, so what absolute value does is if the y values are negative, they become positive. So you can kind of think of it like this. That's the symbol for it. Right? And we all understand that means multiply by -1 if it's negative, right? So here's y equal x. And if I were to draw in a different color, the absolute value of that, well, these y values are already positive. These ones are going to flip over the x-axis. So you get these V-looking graphs, and that's y equal absolute value of x. So that's the graph we're starting with. Okay? And if you ever have a transformation, every once in a while on the exam, they throw in absolute value graphs. If you have one of those, you need to do the absolute value first. Okay? Like, if I go down to my final function here, what you're going to do is, the absolute value is almost like brackets. It's like, I need to do this stuff first. I'm going to do absolute value of this stuff. Then I'm going to multiply whatever graph I get by a quarter and then move it all up by 4. Okay? But let's watch what happens as we start. So first we do this. Then we do this. Okay, so all that's going to do is going to multiply, what would we call this, I guess? Is it a horizontal compression? It's a horizontal one because it's on the X. So this is going to be taking my XY points here. Okay. This one is going to do what? It's going to take them and it's going to go, it's on the X. So it's going to be 1/2 X comma Y. Do we agree? Right, so what is that going to do to my absolute value graph? Well, you take the X values and multiply them 1/2, they get tighter, so it's going to squeeze it up. Then we do a 1/4. Now, is this affecting Y or X? The Y value, so now I'm taking this, and now I'm going to take my points. I guess I'm just going to go down. So I'm going to add this one on, this transformation. So it doesn't do anything to the X's, but it does make my Y values get multiplied by 1/4. Now right here, this is what kind of shift? It's horizontal shift. So it's going to write hor shift. Right? And it's going to be 3 units to the left. So it's going to be subtracting 3. So now my point becomes 1/2 X. Then I subtract 3. And no changes to the Y. So still 1/4 Y. And then the last thing that's new is this one here. So now we've added a vertical shift up 4 units. So that's going to be on the Y value. So that's what I had before, and then just add 4, done. So when it says describe how they're related, you could say that. Does anybody have those keywords on? Are we allowed to use math if it's a describe question? Remember I gave you that list? I don't think we're allowed to. I think we have to use English. Does anybody have that list? I'd bring it up, but I'm recording. But I'm pretty sure describe means only English. So you'd have to say something like, okay, multiply the X values by 1/2 and then subtract 3. Multiply your Y values by 1/4 and then add 4. That's how you can say it in English. Now I'm not going to write that out because I'm lazy, but you could definitely write that. You're not allowed to say like, oh, here's the answer, and just write that. You get 0 if it says describe. If it said justify, then that would be sort of strangely worded. But if it said justify, I don't know, the difference or something like that, you're allowed to use math if it says justify. Yeah. So in which case you would be able to write this down, and I'd be able to consider it as part of your answer. Okay, so what's the big deal? Here it is. Everything we've done together, all at once. So when we factor all our transformations, we arrive at something that looks like this. These are the letters we're going to be using to refer to all the transformations. Okay, so A and K are the ones that affect the Y variable. Okay? So if you just want to write Y values right there. And then B and H, if I use a different color here, those are the ones that affect your X variable. So X values. Right? And we know that, K is a vertical shift up or down. A multiplies your Y value, so it's either going to be a stretch or a compression. Notice how this has been factored, right? This is in that factored form in here. So if the X coefficient is not +1, you need to pull out whatever it is, and then that's the value of B, okay? Which is going to be your stretch compression, your horizontal stretch or compression, and then this is going to be the horizontal shift. Always opposite sign, right? Like with the X transformations, it's almost the opposite, right? Like if it's ×2, you divide by 2, right? If it's subtract H, you actually add H, right? But the Y transformations, what you see is what you get, all right? Now, I think down here, is this in your notes? No? I don't write it down because I think there's a way easier way to write this. But I'll just leave it up for a second in case anybody wants to pause the video at some point. Just talks about the order you should do it in. I found this a few years ago and I thought it did a pretty good job. The most important thing that we're going to talk about is how you need to follow order of operations. Okay, so the steps basically just follow order of operations, and that's exactly true. So anything in parentheses, and I would write abs, as an absolute value. There's always a question on the exam every once in a while. There was one year where there was a couple, it was a brutal exam, like where they have like an absolute value. You got to do that first, and then you do the other stuff. Okay. So absolute value, as far as order of operations go, kind of falls in the parentheses category almost. So I think you have the next page of this one here. So this is just from our old textbook. I like this one because it's just like you take a point x, y on the graph of y equal f of x, and it corresponds to this point, using those letters from before, on the new graph. Okay, now they have a slightly different way of writing it, like they go y minus k. We don't write the minus k, we just go plus k. So if you want to change that, so that way it says y equals. But yeah, take whatever your b value is and go x divided by b, and then add the h value, right? So always the opposite sign, and then go a times y plus k. I like this because it's like, here's what you do. That's how you do a general transformation. Now let's practice with a point. So if we take the point 8, negative 4, we say its original point, it's on f of x, then what would be the new point on this graph? Well, let's practice doing this. I think it's a good idea to write your transformations out. Okay, so if you want to look at the y ones first, here they are. Okay, so I'm going to go 2 times y plus 2. So leave myself some room for x, and I'm going to go 2 times y plus 2. So that's what happens to the y value. Now the x value, remember, this is your b term, and you divide x by it. So I'm going to go x divided by 2. And then, is it add or subtract 2? So, add, yeah. Yeah, I meant what you're actually doing. Yeah, so you're going to add 2. Okay, so that means we're going to take the 8. We're going to divide it by 2 and add 2. So there it is. 8 divided by 2 plus 2. That gives us, 4 plus 2, so 6. There's the x value. Now the y value, we're just going to go, it's negative 4, and we're going to go negative 4 times 2 plus 2, so you get negative 6. You're done. So tip, in general, you can think of working from left to right, right? So like start on the left, and you can do the x value stuff, and then start on the left and you can do the y value stuff. Does that make sense? And when I say the y value stuff and the x value stuff, I mean the transformations. Right, so I recommend tackling it one coordinate at a time. So like do your x stuff, then do your y stuff, or something like that. At the end of the day, you really are just following order of operations. Okay, so please add this. We talked about it in the previous lessons, right? But you are. Want to toss that back to me? I was making a dramatic flare. Yeah. Whoa, a low toss, but I got it. Practicing my skills in the pool area the other day. Yeah, you are doing order of operations. So that means multiplication and division come before addition and subtraction. But you are doing the x and y transformations independently of one another. Okay? So it doesn't matter if you do the y ones first and then the x ones, or the x ones and then the y ones. You'll get the same answer as long as you're following order of operations. Okay? If you get that, this stuff is all pretty straightforward. Like this is the key. For sure. Okay. So we'll do a couple examples. I'm not going to do every single one. There's a couple in my notes that are sort of a little too hard, so we just don't do them. I like to stick to the difficulty of the exam. Don't want to go easier, but also don't want to go harder. Okay, so let's see, first example, yes. I call this the exam special, because this is totally an exam type question. They've indicated 3 or 4 points, and then they give you like the blocky. They don't like doing really curvy graphs on the exam, I noticed. It's almost always a blocky line type graph. And they may give you the equation, they might describe it in words, so be kind of prepared for everything. So it says, here's a graph of y equal f of x. Sketch and label its image after a horizontal compression by a factor of 2. So horizontal is x or y. Yeah, so it's like, okay, well that's an X thing. So horizontal compression by a factor of a half, and then a translation of 3 units left, also an X thing. Yeah? So what we can do is we can sort of write, you might want to make a table, like they're not going to give you the table on the exam, by the way. You know, horizontal compression by a factor of a half means that you are going to be dividing your X values by 2. Okay? So horizontal compression means you're going to squeeze it together, so that means dividing by 2. Maybe that's one way of remembering. And then translation of 3 units left, so subtract 3. Nothing's happening to the Y values, so we just leave them alone. Okay? Now grab these points. Again, I recommend you work left to right. And then when you connect the dots, we'll be connecting them left to right. So we got -4, 3. So -4, 3. I'll just read them off my book. Then we got 0, -2. And then the next one is 2, 5. 2, 5. And the last one, 4, 2. Yay! And then, since we're nice and organized, then we got our original points, and we got our transformation. Just do that to each X value, and then you're rocking and rolling. I'll switch colors, just to go easy on the eyes here. So, -4 divided by 2 is -2, subtract 3 is -5. So you get -5, 3. And then 0 divided by 2 is 0, subtract 3 is -3. So you get -3, -2. Now 2 divided by 2 is 1, subtract 3 is -2, 5. And then 4 divided by 2 is 2, subtract 3 is -1. No change to the Y. Any questions there? And then just make sure you go and plot them properly. So on our graph, let's see what we can do here. So -5, 3. So that would be here. And then we have -3, -2. So that looks like it was that point that went there. And then -2, 5. So that's that point that went there. And then -1, 2. And then connect from left to right. I'll do my best. Kind of make the dots nice and big. They're harder to miss. There. And then usually, like, I'll take a look at it. If I was writing the exam, I'd be like, is that reasonable? Like, okay, so it bunched together. That's what I was expecting. And then it shifted that way. Okay, it looks okay. You know. Questions? How many marks do you think that'd be on the exam? 2. Yeah. Yeah, 3's a good guess, but it's 2, so generally they'll do 1 mark per transformation. So you could draw anything. As long as I shifted it 3 units, like to the left, they give you that mark for the shift. And then they give you a mark for the compression, generally. Yeah, every question is a bit different, but in general, that's what they would do. Now, what else do we have? Right, we got this question. So you might have to take a couple page flips, because I've skipped a couple weird graphs, maybe. Was it just the next page? Mary? Yeah?
Yeah.
Okay, good. So, good. Perfect. All right, what do we got? Okay, just some practice taking some of these and transforming 1 point. So it's 8, -4. Now what I'd like us to do is if you could write the transformation that's happening over here. So if you could write, let's see, as we go from left to right, we have 1 transformation to the Y variable, and what's happening to it? What am I going to do to my Y variable? Times by 3, okay? And then the X variable, so there's a 4, so that means X divided by 4, and then plus 1, so subtract 1, always the opposite. So that's my transformation. So now 8 divided by 4 is 2, subtract 1 is 1, and then -4 times 3 is -12. So there's that first point. Okay, brand new question, same coordinate. Take a look, write out for yourself what's happening. So I'm going to do the X value first. So I look from left to right. There's no adding or subtracting in here, so I can look at that 1/2. And again, you divide X by 1/2. is the same as multiplying x by 2. Is everybody comfortable with that? Yeah? Okay, so go 2x, and then 2 times y plus 3. So 2 times y plus 3. My point was 8, negative 4, right? Okay, so my y, or my x variable goes to 16. 2 times 8 is 16. And then 2 times 4 is 8 plus 3, 11. Oh no, it's negative 4, isn't it? Someone can, is it negative 4? Ah, my bad. So 2 times negative 4 is negative 8, plus 3 is negative 5. Alright, next one. So what's happening to my xy coordinate? Let's see. To the x one, we just go x minus 2, always the opposite sign, and then I'm going to go negative 4 times y plus 6. Okay, and the coordinate is 8, negative 4. So the x coordinate goes to 6. 8 minus 2 is 6. And then negative 4 times negative 4 is 16. Plus 6 is 22. Is this correct? Excellent. Now, this one's looking a bit trickier. So, the b value has been pulled out for us. I can see that because of the brackets. So, my x variable is going to be x divided by negative 2, and then plus 1. Okay, so opposite sign in there. And then be careful because there is a negative on the f. Did you guys catch that? So what does that do to my y variable? Multiplies by, very good, negative 1. So I've got negative y, and then subtract 2. It's kind of an ugly one, lots of negatives. So 8 divided by negative 2 is negative 4, plus 1 is negative 3. And then, let's see, negative 4 times negative 1 is positive 4. Subtract 2 gives me 2. Now, this isn't really a trick question. It's just more like a question of, do you know what you're doing? You'll notice that the coefficient on the x is not positive 1, right? If it isn't, you need to pull out whatever it is, so in this case a 2, to make it positive 1. So if I was to rewrite this for a moment, I'll write it up here. I would go pull out the 2. 2x divided by 2 is x. Negative 4 divided by 2 is negative 2. And there it is. Now I can see clearly what it is. So on this one, I'm going to go x divided by 2. And then I'm going to add 2. No changes to the y value. So let's see, x was 8. So 8 divided by 2 is 4, plus 2 is 6. No changes to the y value. All right. Good. And then the last one, again, lots of stuff happening. I'm noticing that I do not have a positive 1 on my x. So what am I going to pull out? A 3. Just whatever the coefficient is, you pull it out. So I pull out a 3. 3x divided by 3 is x. 6 divided by 3 is 2. There. And then I have to subtract 1. So now that I can clearly see my b value, I can say, okay, well, it's my x value divided by 3. And then subtract 2, always the opposite sign. And my y value is going 4 times y, subtract 1. There. It's a bit ugly, because isn't my x value 8? So I get like 8 divided by 3. Subtract 2, which would be 6 over 3. So what do I get? 2 over 3? I just got a common denominator, right? I had 8 over 3 subtract 2. So I made 2 something over 3. So 6 over 3 is 2. So yeah, I get 2/3. Doesn't happen often on the exam, but obviously you need to be comfortable with fractions. This one here, when you get negative 16, subtract 1. So you get negative 17. Does everyone agree? Yes? Excellent. Right. So that was some practice with just coordinates. Yeah, we can do this one. This shouldn't be a horrible one. I could see something like this happening on the exam, maybe. Now you'll notice though that they usually indicate some points for you. I'm just making them stand out, but those are the points they've indicated. So I'd recommend that we make our little table and then we apply the transformations. Here, they do not need to give it to you solved for y. right? So the first thing would be solve this thing for y. So add 6 to both sides. So I'm just gonna kind of be lazy and put it over there. So now I can see. So let's make our little xy points. So those will be the original points. And then what's happening here? So to my x variable, it's going to be x divided by 4, because that's the coefficient there, and then subtract 2. And then check in front of the f. There's no negative, there's no number. So to the y values, I'm just going to add 6. All right, let's grab these points from left to right. Be careful of the scale. The y values are going up by 2. The x values are just going up by 1. So we have negative 4, 12. And then we have negative 2, 0. And then we have the point 0, 4. And the point 2, 0. And then 4, comma 12. There. So I'll do it in blue. So let's see. X divided by 4 subtract 2. I get negative 3. Does everyone agree? Okay. And then y plus 6 will be 18, because it's 12 plus 6. Now the next one, I'm going to get negative a half, subtract 2. So I do recommend that in those cases you just write it as a decimal. So I get negative 2.5. And then 0 plus 6 is 6. Now 0 divided by 4 is 0, subtract 2 is negative 2. And then 4 plus 6 is 10. And then I'm going to get a half again, subtract 2. So I get negative 1.5. And then 0 plus 6 is 6. And then 4, 12, well, it's going to be very similar to the first one, except I'm going to get positive 1, subtract 2, so I get negative 1, and then 18. All right. Then you just got to successfully plot those points and connect the dots. I will say, generally on the exam, you don't see many decimal values. Like usually the numbers work out nicely, but so this question might be just ever so slightly harder than one you might get on the exam, but it's a good one. So let's see, negative 3, 18. So that would be right here, this is 18, this is negative 3, so dot right there. And then negative 2.5, which would be right here, 6. So that would be 8, 6 would be right here. And then we go negative 2, 10, so that's right there. And then negative 1.5, 6, so that's back down here. And then negative 1, 18, there. And then look at the original graph. So it's kind of rounded, right? So when you do your sketch, try to get the same thing. So it should look sort of similar. So maybe something like that. This textbook doesn't ever use the arrows, but there should be arrows on there, so you could toss them on. Questions? How many marks do you think that would be? 3. It's usually 1 per transformation. Yeah. So we had 1, 2, 3 transformations. Okay. Question? On the next example, now I've never. Oh, that's the same one, just so you could work on it. This one has asymptotes. I've never ever seen them getting you to transform a graph like this on the exam. Okay, so you can see there's an asymptote here, and then there's clearly an asymptote here. All I wanted to point out here, because sometimes they ask domain and range type questions. So while I've never seen them say, hey, take this graph and actually sketch out the transformation, sometimes they'll ask questions about domain and range. So they'll be like, you know, here's the function, either as a picture, or here's a domain and range, here's a transformation, what's the new domain and range? That's all I want to do with this one. Okay? Because I want to point out that the asymptotes also shift. Okay? So here's our transformation. Let's solve it for y. So let's subtract 4. So what's going to happen? We're going to take an xy point, and it's going to go to, let's see, x. X divided by a half is the same thing as 2x. And then subtract 1. Anything else happening to the y? Just subtracting 4? Yeah? So all I want to point out is that if you were transforming this, and because it does sometimes come up as a theory question or whatever, the asymptotes do the transformation as well. So you have x equals 0. What's 0 times 2? 0, and then subtract 1? Minus 1. So the new, which one are we doing? We're doing the horizontal asymptote. The new horizontal asymptote is now x equal, oh, that's a vertical one. Oh, do I have these mislabeled? I do. I was like, what's confusing me? I have these mislabeled, right? Let me try again. You guys are sleepy because it's Monday, right? So this is x equals 0, this is y equals 0, my bad. So let's see, the new vertical asymptote. Yeah, take that x equals 0. 2 times 0, 0, subtract 1. That's the new vertical asymptote. The new horizontal asymptote, let's see. Well, it says y minus 4, so it's going to shift down 4 units. There. That's all I really wanted to talk about on this question. Okay? So now you guys are aware that asymptotes also shift. Of course, they have to. The whole graph is doing that shift, is doing that dance. That's all we're going to do. Now this is the same question, just for you to write on. Now this one is, they do like to transform square root functions. So this one is something that could happen to you on the exam. But the same procedure as before. So I've got all this writing and stuff, just breaking it down for you. But yeah, we're taking y equals square root of x. And now watch the scale. Right, it's going, the x values are going up and down by 2, and the y values are not. They're going up and down by 1. So this is the point 0, 0, and then the point 1, 1 is right there, and the point 4, 2 is right there. So it's a bit more zoomed out than what we're used to. We're going to take this one, and we're going to do this transformation. Okay, so let's subtract 1 from both sides. We'll ignore the question mark. So let's see if this makes sense. We take our xy point. What do we need to do in here? Do we need to pull anything out? Yeah, notice how the coefficient of the x is not positive 1. If it isn't, pull out whatever it is you need to pull out, and then divide each term by it. So we're going to get x subtract 3. So there it is. So I'm going to divide my x terms by -1, so you get negative x. And then add 3, because it's -3, so that's what's happening to the x variable. On the y variable, we've got 2 times y, subtract 1. Does that all make sense? All right. Now take those convenient points, right? Take the 0, 0, you know, the 1, 1, and the 4, 2. Now, we might need other points. Let's just start with that. What happens? To the x one, we get 3. And then to the y one, we get -1. Now, -1 plus 3 is +2. And then we get 2y, so 2 subtract 1, so we get +1. And then for this one, we get -4 plus 3, which is -1. And then 2 times 2 is 4, subtract 1 is 3. There. Let's see if that's enough for us. I'll use red. So 3 for x, which is here. And is it -1 for y? Yes. So 3 for x, -1 for y, which is right there. And then 2 for x, 1 for y, which is right there. And then -1 for x here, and 3. Now if you're looking at that and you're not sure about what to do, you might want to grab a couple more points if you can. I don't know if there's any other convenient ones. You know the original equation, right? It's the square root of x. So you could go get a couple that aren't on the graph. You can also look at the transformation and be like, okay, what's happening here? So this negative here is going to cause some sort of flip, isn't it? Over which axis? Yeah, so whenever you have a negative here, you have a reflection in the y-axis, so this thing's going to flip over. Right, so I am expecting it to open that way because of this -1, it's going to flip over, and then we're going to go 3 units that way, and then there's a vertical stretch, so it's going to kind of get longer and skinnier, and then we're going to go down 1. So this kind of makes sense to me. I'm like, okay, it's going to be going this way, there. That would be enough for all the marks, and that would be 1, 2, 3, it'd be like 4 marks on the exam if it were to happen. drawing a blank on whether or not there's ever 4 mark transformation questions. Definitely see 3 mark ones all the time. So, alright. As a try it yourself. I think in the interest of time, we can skip it. Yeah, we'll just skip it, but very, very similar. Same thing with this one. There is one last thing I want to definitely get to, it's this. The final topic is going backwards. So it's when I give you the transform point and I say, okay, well, what was the original equation? Or state the equation in terms of f of x or something like that. Okay, so it says here's the point that's on f of x. What would be the points according to the following instructions? Well, I'm not too worried about that. For each of the above, write a new expression of the points transformed by, let's see. Oh, transformed by the instructions. So I'm looking for it in terms of f of x. That's the thing I'd really like to work on. I'm very confident that you guys can do those transformations if I give you a point. But what about writing it in terms of f of x? That's all I want to do with this slide. Writing it in terms of f of x. So going backwards. This would be your b value, right? And then we have a translation down 3 units. So this would be f x divided by 2, right? It's always the opposite. And subtract 3. Do you agree? Yeah. This one, no b value for x, but we are subtracting 3, so it would be x plus or minus 3 in here. So always the opposite. And then 2 times y, well, that number goes in front of the f. So there we go. This one here, always the opposite. So if it's multiplying by 2, you're actually going to be dividing your x value by 2. And then that's it for x, and then 2 times y, so 2 times f. Okay, it's dividing by 2 on the x, so that actually means that we are going to multiply by 2 in the original equation. No other transformations. And now, y divided by 3, so that would have meant that there was a 1/3 here, because you just multiply your y values by whatever's in front. That one was a bit trickier. Now the last one is tons of fun. Because you have to be very, very, very careful here. So there's a 2, there's 4 transformations happening here. So let's do the x ones first. So 2 times x, which means that it would have had x divided by 2. Do you guys agree? Okay. But then I got this subtract 3. Right, so I need to think very carefully how I'm going to do this, because I can't just, can I just go like that? No, because that's not the way they would have written it. I need to write the 1/2 in front. Okay, so I need to take that divided by 2, go 1/2, and then open a bracket, x minus 3 there. Right, so now I got my b value, which is 1/2, which means I multiplied by 2, and then I added 3, so it means to subtract 3 on the inside. Now for the y values, we got divided by 2, so that means 1/2, and then a subtract 1, so subtract 1 out there, and you're done. Alright. Okay. So again, I'm not concerned about doing this stuff. I know that you guys can take a point and do the shifts. We've been doing it for a long time now. Now these last couple questions, I don't like them. They don't print very well in your booklets. Like the points are, because you don't have the different colors, it's really hard to see. But this is one where they're giving you the 2 functions and you got to come up with a transformation. Occasionally it happens on the exam. They give you the 2 functions and they say what was the transformation, right? We did it at the beginning. I might just say let's just open up an exam and see if we can find some questions for transformations now. Okay. Last time I edited out of my video that whole stretch. There was a 3-minute stretch where we didn't find anything. Okay. So before we go to the exam, we'll skip those. I'll just point out that this is what you guys need to do. So 3.4 for homework. Tomorrow I'll give you a supplement and we can work on tomorrow. Maybe I'll start giving you a practice exam tomorrow. and a supplement. There's a practice exam at best is gonna have like 6 or 7 marks on transformations. That's like 2 or 3 questions. Okay, and then you can do everything else that we've done, and we can do the supplement sheet, which would be just on transformations. So let's see if I can find anything. I didn't look ahead of time. I was up late last night watching what's that? Altered Carbon, season 2 on Netflix. Nobody? How many of you are watching that dating show? It's the one where like they don't get to see each other, and then they have to get engaged.
Oh, is it like
90 Day
caves?
90 Day
My
Fiancé.
sister is obsessed with that.
I saw on Netflix it was #1 trending in Canada like all weekend long, and I was like, I'm gonna watch this show. I usually don't like, and I was like, it's insane. I thought it was pretty funny. And then I kind of got hooked. I'm like, which one of these couples are gonna last? And it's like watched like 4 episodes. And then I felt bad, so I went for a run. Felt bad about seeing next. Let's see. And then I made cinnamon buns, you guys. Oh my goodness. I gave them all away. I had to give them all away to my neighbors and stuff because otherwise I ate like 2 cinnamon buns in like 10 minutes. Okay. I should show you guys a picture. Let's see. Let's find. Let's go back to the good old days of June 2018. Oh, here's our terminology sheet. Describe, just from before, use words. And describe is use words. Explain is use words, basically. Justify is when you can actually show some math. See, supported by mathematical computation. The last year's exam, they had lots of justify questions. They started realizing that people were screwing up explain ones because they wanted to use math. So I noticed there was way more justify questions. Like 2 or 3 years ago, everything was like explain, and oh boy, did people hate it. So there it is. Okay. Can't do it. 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 Yeah. Oh, can't do it. It's a trick question. Can't do it. Here's one. You can do question 10. State the equation of g of x in terms of f of x. Yep. That's exactly right up our alley. So I'll give you just like 30 seconds to try it out. You don't need to necessarily write it down. Just see if you can get the answer right. Well, the transformation is getting applied to f of x, resulting in a new function. So you're going to write, I hope that comes through. Is there a way to make the pen thicker? I don't know. So g of x equals something with f of x in it. So when it says in terms of f of x, that means use f of x. So reflection over the x-axis. So we could do this. Reflection over the x-axis means what's getting multiplied by -1, x or y? It's the y values. If you ever forget, draw yourself a point and be like, okay, I'm reflecting over the x-axis. That would be down here. Oh, it's my y values that's changing. So, okay. So I have -y. A vertical stretch. Vertical stretch, that's your y values by a factor of 3. So I get -3y, actually. And a horizontal stretch by a factor of 4. So that's on my x values, right? Now on the exam, horizontal stretch means they're going out further, so that should be a 4 times x. Do you guys agree? If it's a stretch. Yeah? Okay. So, writing it in terms of f of x. So let's see, I'm going to go -3 f of x. So f, open a bracket. Now I got to write, if I'm multiplying by 4, that means I would write 1/4 x, or x divided by 4 would be appropriate. And I believe that's it. Notice how it's 3 marks, and there are 1, 2, 3 transformations. So they see the reflection as a separate one. So if you just wrote -f of x, you get a mark. If you just wrote 3 f of x, you get a mark there. Okay, so You can get any piece wrong and still get the other marks. Okay. Now we should quickly check the solution B. This is question number 10. I encourage you to go find these online, like I showed you. And yeah, it looks like we got it, so that's good news. There's the mark breakdown. Whoops. So you can see there's just one marked right. Alright, let's see what else we got. We can do this question. So here's f of x. Notice how it's very blocky, right? It's a 3-mark question because there's 3 transformations. So get a quick sketch if you can. See if I can help you out here. So you got the point. This is the point. No, I don't want to write on there. I'll do it over here. Starting on the left, we got -3, 1. And then we got 0, 1. Two, -2, and then 3, 0. Now what's happening to my xy point? So subtract 1 from both sides. So my y value is going to be 2y subtract 1. And my x value just has a horizontal translation, so it's going to be x plus 3. And then happy transforming. So you're going to get 0, 2, subtract 1 is 1. And then you're going to get 3, comma, 2 times 1 is 2, subtract 1 is still 1, yeah, okay. And then you get 5. You get -4, subtract 1, -5. And then 3 plus 3 is 6. 2 times 0 is 0, subtract 1, there. And then just plot them successfully. So 0 and 1, it's right there. And then we get 3 for x, 1 for y. And then we get 5 for x, -5 for y. So 1, 2, 3, 4, 5. And then 6 for x should be there, and -1 for y. Now before I connect them, I always kind of look back and be like, yeah. So what happened? We shifted 3 units that way, so that kind of makes sense. And then the y values got multiplied by 2, so they jumped up and then we went down. Then I might be looking and be like, if I went down 1, why am I still on this same horizontal plane here? Why? Because before we went down 1, we also multiplied them by 2, and 2 times 1 is 2, and then you go down 1. So that's kind of sneaky. Okay? Because then it's kind of like, to me, I look at that, I'm like, whoa, if I went down 1, why am I still here? But it's just the way it worked out. So connect from left to right. Something like that. Watch if there's arrows, right? If there's dots, maintain the dots. If they had an arrow here, I would have maintained an arrow there, right? So don't mess up those things. Questions? Excellent. It's kind of nice that we can flip through an exam and there's actually a couple questions we can do now. You guys know how to do it. It's just a different unit. I'm going to skip it. We know how to do it. We'll just skip it. Don't know. Don't know. Don't know. Don't know. Okay. So that was the calculator booklet. We have a little bit of time. Maybe we can squeeze in a couple more questions here from book 2. So this is the no calculator booklet. You can do 18. Let's quickly do it. So what are they doing? They're saying f of x is x minus 1. So, and then they're saying y is the square root of f of x, so it's that graph. So then think about your coordinates that you know on the square root of x, right? We got that, we got that. That would be a good place to start, as those basic points. What's happening to the x value? We are adding or subtracting 1 to it. Adding 1. Y value doesn't change. So do you see anything that sticks out at you? I heard someone say it. C should be a point on the graph. You can also double check. You can plug in x equal 1 and you get the square root of 0, which is 0. So it works. It's definitely a point on that graph. Questions? No? Okay. Can't do that one. Can't do that one either. Can't do it. Can't do it yet. We can do it. Should we do it?
Yes.
I don't know. It's a cubic function with a y-intercept of -12. It's not a question from this unit, but let's see. A y-intercept of -12, so that would be 0 for x, -12 for y is a point on the graph. Find the missing factor m. So plug in x equals 0 and p of x equal -12 and solve, right, is basically the question. So you get 3m times 0 plus 1 squared. Oops, missed my 1. So that's just 1. So it's basically -12 equals 3m. So what's m then? -4. Okay, now it's a little tricky because it's like, but which factor is m, right? It's a cubic function, so this is going to be x plus or minus a number. The missing factor m. Yes, very nice. Which one? It's definitely not this, and it's definitely not this, right? What do you guys think? A? Anyone for B? B? Yeah. Let's see. I'm gonna take this under the marking, guys. This is question 23. It is A. Right? Why? Because where did it go? My m value is -4, right? So it's x minus 4. It's just whatever you see. So there you have it. Where'd my little pen go? I don't know how I had the pen. That's a highlighter. I don't know how I got the pen the first time. Is it this one? Okay, anyways. Okay. No, can't do it. We could do this one. Given x squared, which equation represents y equal f of x after translation of 5 units to the left? Be careful. A, B, C, or D?
D.
No, it's to the left, so it's on the x value, so it's definitely not C and D because that's changing the y values. Now, if you want to go 5 units to the left, what do you guys think? Yeah, definitely A. Yeah. Okay. We can do 26, but we won't. We can do that one, but we won't. We just kind of want to stick. Haven't done it yet. Do you guys recognize this one? It's very similar to that one question we had about someone being above or below the water. Very similar. It's not the same one, but it's very similar. Not yet, not yet, not yet, not yet. We can do it, but we won't. I think that's it. It's 11:07. We have 2 minutes left. Got some extra practicing. See you next time.